Good day, Professor. Today, I have chosen to bring optimization in hospital instrument sterilization process with AI and automation, and I'm going to present the business process model of my optimization. Therefore, the process name is Hospital Instrument Sterilization Workflow. The process starts when used instruments are sent for sterilization, and the process ends when sterilized instruments are returned and ready for use. Hospitals process thousands of instruments daily, and delays can cause surgical disruptions. Manual tracking leads to errors, misplacements, and sterilization failures. Contaminated instruments increase hospital acquired infections. A case study in Australia, hospitals found that sterilization bottlenecks caused surgery rescheduling due to delayed instrument availability. 40% of sterilization failures are due to human error in tracking and handling. So, how a current hospital sterilization process works? It starts with used instruments collect. Here, instruments from surgeries or procedures are gathered. Then, manual sorting by staff. Staff manually separate instruments based on type and contamination level. Pre-cleaning required. Instruments are inspected for contamination. If contamination is detected, they are sent for manual pre-cleaning. If yes, manual pre-cleaning by staff takes time and may be inconsistent, or select sterilization method depending on the instrument type. Staff choose between autoclave process, which is steam sterilization, or chemical disinfection, or gas plasma process. Manual security check by staff. Staff verify sterility here, introducing potential human error. If passes, sterilized and ready for use. But if it fails, repeat sterilization process here again, and these usually cause delays. So the challenges in the current systems are processing bottleneck, instruments are pile up, delaying sterilization, and risk of proper cleaning, manual sorting and validation introduce contamination risk, and also manual validation errors like bring higher chances of human mistakes. So here is my proposed optimized hospital sterilization process. So how it works? So usually it starts with the same process as it exists nowadays, and it is used instruments collected, and then automated RFID scanning and sorting. The instruments are scanned and sorted automatically, reducing errors. And then AI based contamination check. An AI system detects contamination with high accuracy. Automated pre cleaning instead of manual cleaning, or AI controlled machines handle pre cleaning. And then we choose the automated sterilization selection. So here, like, the system determines the best sterilization method based on material and contamination level. So the methods are steam, which is the autoclave process, chemical disinfection, and gas plasma sterilization. So automated sterility validation happens here. So AI-based validation ensures sterility is achieved. If it passes, sterilized and ready for use. But if it fails, an AI triggered reprocessing happens here, which basically automatically detection of failures, and then it brings back the process here. So there are some other things like we employed here, like the automated validation, which basically minimize the human errors, and automated tracking here. So that prevents the item loss. So the key improvements made here are: the RFID prevents item loss, which ensures every instrument is tracked; more accurate contamination detection, so AI reduces false negatives and reduces processing time. No more manual sorting delays here. And it also minimizes human error. Automation eliminates mistakes in validation and sterilization selection because it's all done by machine. So there is very few chance to have error here. I would also like to discuss implementation strategy of my proposed optimization process. So here it goes. So we have to equip all surgical instruments with RFID or barcodes for tracking, and then deploy AI-powered sterilization monitoring software, and then train the sterilization staff and nurses on the new automated system. We have to run a pilot program in high volume hospitals before full scale deployment. Some of the exceptions and variations may include: if damaged instruments detected, flagged for replacement instead of sterilizations; unscannable RFID tags, manually tracking is used as backup; and emergency surgery request where fast track sterilization process activated. Entry criteria, inputs, and dependencies are: like for entry criteria and inputs, so used surgical instruments collected from operating rooms, RFID barcode scanning initiates sterilization tracking, AI system identifies sterilization method, steam, chemical, or plasma. The exit criteria and outputs: instruments pass sterility validation and are ready for use. Real-time updates ensure availability for next surgery. Dependencies: reliable RFID barcode infrastructure, AI system trained with contamination detection data, continuous system audits for accuracy. So the key takeaway message from this process optimization is, like, this process introduces automation, AI, and RFID tracking, leading to faster, safer, and more reliable sterilization with minimal human intervention. This is not only reduces contamination risk but also improves hospital efficiency. Thank you all. Thank you.